Good morning!
Hi!
We're back for the next exciting episode of
The Harkin and Henning Show.
The Harkin and Henning Show!
Yay!
Hey, it's getting kind of warm outside.
Oh,
Miss
yeah.
Harkin.
It's getting a lot hot.
So I think, that kind of reminds me of phase changes.
Oh, yeah.
And states of matter.
Oh, yeah.
I think we should teach the kids about that.
Let's
now.
do it.
All right.
Okay.
Something like that? No? Next. Okay. Oh, what's all this, Miss Harkin?
Oh, kinetic molecular theory.
Ooh, we better get look at all this information. We better get our science notebook out.
We better write this down.
Ooh, I wouldn't necessarily write it word for word, but I definitely would be compiling a good list of that.
Yep, I'd make sure I had some stuff down.
So kinetic, if I remember right from all my...
Oh my gosh, it's been so long ago. Kinetic energy.
Kinesiology has to do with movement.
Yes.
Do I remember that? And doing kinesthetics,
Uh-huh.
jumping jacks, all that kind of good
And
stuff.
kinetic energy. From the
Kinetic
beginning.
energy? I forgot about that.
Yeah, that's movement.
Yeah, that's right. So this is really about how molecules move.
Ooh, I like that.
And of course, we can't see them, so it is a theory. It's not a fact.
But we're pretty certain.
Yes.
Yeah.
A lot of things that we've done, not we.
Yeah.
Scientists.
Scientists.
Yes. So first we know, of course we know matter. We know those three key words we learned about matter. It's made of atoms, takes up space, and has mass. Yep. So we're talking about these molecules in these atoms moving. So I would put that down.
I would write that down.
Molecules are moving.
They're moving.
If they move faster, that means they have a higher temperature.
That makes sense.
If they're moving slower,
Lower temperature.
lower temperature. Oh, what a cute
little
little
picture.
States of matter. Oh, look at there they are. But I think one's missing.
I think we're missing the P one.
The P1, but we'll wait on that one. So we're just going to go over each one of these and what the molecules look like. These are really good to write down word for word.
And you might want to draw a little picture.
Yeah. States of matter. Solids, and I love this picture because it shows how organized they are, how close they are. They're really stuck together. And then we have...
Oh, so some things to write down. They're super rigid.
Which means they don't really move. They
Yes.
do move, but they're just vibrating. It's like spaz.
They can't move because there's so many things there.
But they're moving in their spot.
Yes.
Come
So
on.
like this.
Yeah. That was good. I like that.
I like that, yeah.
They're really, really strongly attracted to each other. Solids, think of, like this table, nice solid. It's very strong attraction, very nice, strong. And then we talk about how the shape and the volume stay. They don't change. So if I put this table in a different room, it still has...
Still a table. Still going to be a rectangle. Still going to have the same shape.
And the
Same volume.
Yeah. That was solids. So get that written down. Pause probably for a second.
I'd pause. Make sure you have that. Make sure you draw the picture.
Yeah.
Yes. So they vibrate in place, but they can't
And really strong, really strong.
They really like each other.
These are like besties.
Besties that are so excited to see each other.
Yes. Yeah, I love that.
Okay.
Next one is liquids. And you can see that our picture has changed.
Yeah, that
We're
looks
not
different.
so organized.
No, and we're not so close together.
And we're not so close together. So they're still kind of close together.
Yeah.
We move a little bit, so now we're
They got a little space. Kind of move around.
moving around. They're not so strong in their bonds.
No.
This is I kind of think of this like in the cafeteria, like each person, and they kind of move around from table to table.
And you kind of like this group, kind of like that one.
Yeah.
Kind of move.
They're not bonded. They don't necessarily stick together so much. I kind of like that.
Yeah.
Oh.
Ooh, new word there. Indefinite shape. So it means it can move and change. Think of water. Like if you spill a cup of water, the water can move and change, and the shape isn't definite.
Yeah.
But the volume, we're gonna always have the same amount of volume.
I think of like my
pop can.
Like my pop can. So it's got the liquid in here has the shape of the can, but then when I pour it in my glass with my ice, then it changes to the shape of the glass.
But it's still the same amount of liquid.
Still same amount. Okay, nice.
Oh, so you should write that down.
I think that's it. Yeah. Yep. And then, look at this picture. Those gases are way far apart from each other.
Yes, and
chaos.
that looks crazy.
Yeah. they're very weak. They hate each other pretty much.
yeah.
They like, if they hit each other by accident, then they're gonna bounce off each other and then go far.
Yeah, they
far
do
away.
not like each other.
They are free to spread out all over. Like you think of our classroom, there's gases all over.
Yeah, and they just can move wherever.
Yep. High energy, so faster moving than the liquids. That's part of being a gas.
Yep.
And they will change their shape
And they can change their volume.
and their volume. So they're going to
Crazy.
match whatever. If you think of balloon,
Ooh, I like that.
yeah, so when you blow up your balloon, that gas takes the shape of the balloon and the volume of the balloon.
Yeah.
But then you let it out, you know, that big
Yeah.
noise that, you know, they make. Then those gases, that fills up this whole room.
Yeah, it does.
So it changes its volume and
And
its
the shape.
Nice. And I think we have one more.
I think so.
That's that sneaky one.
This is sneaky.
Yeah.
People don't know about this
Yeah.
one.
It's plasma.
Plasma.
Plasma is the fourth state of matter, and it's basically a super, super excited gas.
Yes, and it's super rare.
Yep. And it's only extreme, and we see it a lot in stars.
Yeah, like the
Oh,
sun.
like that. Yeah. Comets, stars. Yeah.
Yes.
Things that are having a lot of energy. It's not necessarily so much moons. They don't have plasma because they really don't have energy.
No. But like the sun, star, comet,
Yeah.
that sort of stuff's gonna have a lot of energy.
Nebulas, you know, all that great science
stuff, yeah.
That's it for right now. We're going to go into a different video and talk about how these different states of matter change between each other, going
Ooh.
back and forth, up and down.
Yes.
Yep.
Okay.
Nice job.